Hello everyone, let's check the sound. How can I do it? I might be just used my iPad. Oh my gosh. One, two, three. Yeah, I think sound is working, so we can start. Just need to select okay, how can I stream manager? Yeah, we are good. So yeah, on the stream I keep reading the Rustlang book, and now we on chapter 3.3. There is the functions. We starting from really basic, so and kind of want to have this like deep understanding, so just reading whole book one by one, trying to understand, discussing it. So let's start. Functions are prevalent in Rust code. You are already seeing one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allow you to declare new functions. Rust code uses snake case as a convenient style for function and variable names, in which all letters are lowercase and underscore separate words. Here is a program that contains an example function definition. Yeah, this like default convenience, I think I like it because I'm currently working with TypeScript, JavaScript world. It completely mess. I actually don't really care because whatever you pick, you're working with different dependency, it will be different and some pieces, so I just ignore this. So having this in Rust standard way is kind of cool. So let's try to write our function. Cargo new functions 3.3. So here is our main function, and let's create another one. And Yeah, we have warning, it's never used, so let's use it in main. Now we just can run cargo run. Yeah, nothing fancy, just works as expected. We define a function in Rust, but entering fn followed by a function name and set of parentheses. The curly brackets tell the compiler where the function body begins and ends. We can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere in scope that can be seen by the caller. So yeah, this is important topic. I guess in some languages order does matter, and if you like call another function before it was defined, you get some errors. Rust doesn't care, so I like it. Let's start a new binary project named functions to explore function fuzzer. Place the another function example in main src and run it. You should see the following output. Yeah, we already did it. The line executes in the order in which they appear in the main function. First the hello world message print, and then another function is called in its message is printed. Parameters. So we can define function to have parameter, which are special variables that are part of function's signature. When a function has parameter, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments. But in casual conversation, people tend to use the word parameter and argument interchangeably for either the variable in a function's definition or the concrete value passed in when you call a function. Okay. Arguments, parameters, like technically it's arguments, but yeah, people call it parameters as well, and this is fine. In this version of another function, we add a parameter. Okay, let's do the same. So value of x argument cargo run. Yep, nothing surprising. The declaration of another function has one parameter named x. The type of x is specified as is32. When we pass 5 into another function, the println macro puts 5 where the pair of curly brackets contain x was in the format string. In function signature, you must declare the type of each parameter. This is a deliberate decision in Rust design. Requiring type annotation in function definitions mean the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what types the function expects. Yeah, actually nothing surprising. It's just fine. You have a function, have arguments with types. So yeah, nothing surprising and unexpected happened to you. When defining multiple parameters, separate the parameter declaration with commas like this. Okay, we can add unit label. For example, unit label okay, and let's run. Still nothing fancy. Yeah, I have a Socaster. My cat keeps screaming. And this example creates a function named print labeled measurement with two parameters. The first parameter is named value and is an I32. The second is named unit label and is type char. The function then prints text containing both value and unit label. Let's try running the code. We already done this. Now, statements and expressions. Function bodies are made up of a series of statements, optionally ending in an expression. So far, the functions we covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is important distinction to understand. Other languages don't have the same distinctions. So let's look at what statements and expression are and how their differences affect the bodies of functions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resultant value. Let's look at some examples. We actually already use statement and expression, creating a variable and assigning a value to it. With the let keyword is a statement in listing 3.1. This is a statement. So basically, this is the statement. No. Maybe something like this. Statement. Function definitions are also statements. The entire preceding example is statement in itself. Statements do not return values, therefore you can't assign let statement to another variable. As the following code tries to do, you'll get an error. As usually, we should to check it. So yeah, we have the error. We can try the run. Still can do it. Okay. So function main is statement function, another function is statement. It's not return anything. Println is macro, I don't know, is it statement? Another function also not return anything. So I guess it's everything here is statement. Function definition are also statement. And okay, we were here and we saw this. The let y equal 6 statement does not return a value, so there isn't anything for x to bind to. This is different from what happened in other languages such as C or Ruby, where the assignment returns the value of the assignment. In those languages you can write x equal y equals 6 and have both x and y have the value 6. That is not the case in Rust. Okay, so we cannot do something like x equal y equal so y equals 6 doesn't return a value, so we can assign it to x. Okay, expression evaluate to a value and make up most of the rest of the code that you write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expression can be part of statements and listing 3.1. 3.1 was yeah, it's confusing, sorry. 3.1, okay. The 6 is a statement. Let y equals 6 is an expression that evaluates to a value 6. Calling function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression, for example. So this is expression, this is like, this is statement, but it sums and return the value. So this is expression, and hold this construction, I guess return 4. So let's just try. So it's function, so we create a function and try expression. Let y equal, let x equal 3 and x plus 1. Yeah, we didn't invoke our function anywhere, so let's do this. Value of y is 4, so yeah, as I thought, it sums and return the value, so it's expression. Let's actually read it once again. Consider a math operation such as 5 plus 6, which is expression that evaluates to the value 11. Expressions can be part of statements. The 6 in the statement let y equals 6 is an expression that evaluates to the value 6. Okay, in this statement 6 is expression that return value 6. Okay, calling a function is an expression. So calling a function, this is expression and this is expression. Calling macro is an expression. So here expression as well. A new scope block created with curly brackets is an expression. So this one is an expression. Curly brackets block is an expression. This expression is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Yeah, this is actually interesting. We don't have it here. What happens if we add it? Oh, you see, if we add semicolon, it's not return the 4 anymore, but it return how it was called actually. Let's back to the data types. The tuple without any values has a special name unit, so this is return a unit. And we can try to display it. Yeah, you see it show empty tuple, so it's unit. Let's try to remember this terminology. But actually, yeah, let's revert those changes and back to our function chapter. Line doesn't have a semicolon at the end, which is unlike most of the lines you have seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of the expression, you turn it into a statement, and it will then not return a value. Keep this in mind as you explore function, return values, and expressions next. Okay, this is actually interesting. Function with return values. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an error. So this is what we should do. And rather, the return value of the function is synonymous with the value of the final expression in the block of body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of functions that return a value. Okay. We would like to do it as well. Return 5 implicitly, and actually it requires return value, so let's see if it gives us an error, and it is mismatch types. Now it's fine. and just thanks Copilot. The value of 5 is, yeah, this is what it is. There are no function calls, macros, or even let statement in the 5 function, just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified to as, yeah. Try running this code, the output should look like this. Yeah, we try to run it. The 5 in 5 is the function's return value, which is why the return type is i32. Let's examine this in more detail. There are two important bits. First, the line let x equal 5 show that we are using the return value of a function to initialize a variable. Because the function 5 return a 5, that line is the same as the following. Okay. Second, the 5 function has no parameters and defines the type of the return value, but the body of function is lonely 5, which no semicolon, because it's an expression whose value we want to return. Let's look at another example. Yeah, before we look into another example, this is like having always return value prevent us from mistake. Like if we put semicolon here, it will return actually the unit. Yeah, and it will work. But since we expect i32 here, if we put semicolons by mistake, we will get an error. I think it's something about, yeah, famous Rust safety. Yeah, let's clear this warning. It's a bit annoying. So 5 is calculated. 7 plus 5, 12. It's fine. Running this code will print, yeah, but if we place a semicolon in the end of the line containing x plus 1, changing it from an expression to statement, we'll get an error. Yeah, basically we just discussed this point. The main error message, mismatched types, revealed the core issue with this code. The definition of the function +1 says that it will return i32, but statement don't evaluate to a value which is expressed by unit. Yeah, per empty parentheses the unit type. Therefore nothing is returned, which contradict the function definition and result in an error. In this output, Rust provides a message to possibly help rectify this issue. It suggests removing the semicolon, which would fix the error. Okay, this is the function chapter. Maybe, yeah, comment is small one as well. Let's take a look at it, and then I think that's it for today. So all programmers strive to make their code easy to understand, but sometimes extra explanation is warranted. In these cases, programmers leave comments in their source code that the compiler will ignore, but people reading the source code may find useful. Here the simple comment. Yeah, actually I'm already using comments a lot because my new Vim configured to have it on the command. I can command line or even selected visual block, very easy. So yeah, but is there anything more about the comments? I don't know yet in Rust specifically. In Rust, the idiomatic comment style starts a comment with 2 slashes and the comment continue until the end of the line. For comments that extend beyond a single line, you need to include another 2 backslash on, or it's just a slash. Slash character looks. Okay, it is slash. Two slashes. Okay. Comment are also be placed at the end of the line containing code. Yeah, like we did it here specifically. But you more often see them used in this format. This is the comment on the separate line above the code annotated. Rust also has another kind of comment, documentation comments, which we'll discuss in the publishing a crate to crates iOS section. Okay, there is something more interesting about the comments, and we will know about it in chapter 42, but not going to dive it today. Let's check what is the next. The next is control flow. So the if-else statements. If else, loop, yeah, if, loop, if. Okay, this will be our next stream, probably tomorrow. Thanks for watching.